Opening the door to let the light in is a lot like how Near-Spec does its job. Let's go inside the Astrium clean room in Ottobrunn, Germany, to find out how. So Rolf, does Near-Spec involve the opening of doors?
That's correct, but our doors are very small. If you have a look here, you see thousands of doors in this array. And it's called microshutter. And if the doors are open, you can have a look to the universe.
Oh, is there any way we can actually see the microshutter array in Near-Spec?
Yes, for that we have to go into the clean room. Our arrays on Near-Spec, we have formed them. They're here within this black arc.
Okay, so there's 4. All right, so you see 2 by 2.
Yes.
Is that the spectrometer that it's in?
This is the entrance of the spectrometer.
My eyesight's pretty good, but it's not good enough to see thousands of little doors or thousands of little microshutters. How can I get a better look?
If you really want to know how these doors are working, you should have to go to NASA Goddard Space Flight Center at Maryland.
Okay, well, sounds good. Well, thank you so much for showing us the microshutters in Near-Spec.
You're welcome.
So Harvey, Ralph from Astrium just sent us from across the pond to find out more about how microshutters work. But first I have a question. Why do we need microshutters on Near-Spec?
Well, in order to tell you about that, I need to remind you that James Webb is supposed to study the universe at a time when the first galaxies are forming. In order to really tell if they are citizens of this very early phase of the universe, we need to do a spectroscopic study of those galaxies. They'll be very, very faint, so it's going to take us a very long time to do those measurements. And after looking at the picture of the sky, we identify where these objects are, and we just open the shutters on each of these locations.
So basically it isolates parts of the universe for you, right?
Exactly. It lets us observe, say, 100 objects at one time rather than just one at a time. So it makes JWST 100 times as effective to explore the early universe.
Can I take a look?
Sure.
All right.
Is this okay?
Yep. Oh yeah, look at that.
Okay, so you're seeing the microshutters there. The array has 250,000 shutters in it. You're seeing only a tiny fraction of what's on there. Now we can move in and see a single door in greater detail. The height of that door is only about twice the diameter of a hair.
What are the smaller rectangles on this shutter?
These are stripes of magnetic material to allow the magnet to open the shutter. Come on in, Mary. In here we have a microshutter array set up where we can open it with a magnet so you can see how the little shutters work.
Okay.
As we slide the magnet across here, it's open and you can see the NASA logo behind it.
Right.
We pull it back and it's closed. When we combine that with our electronics, we can actually open any single shutter in the entire array.
Well, Harvey, thank you so much for helping us understand how microshutters work on Near-Spec.
Well, thank you very much for the opportunity to show them off.
While this new technology was developed specifically for Webb, the use of microshutters is being planned for other telescopes. Thanks for joining us for this edition of Behind the Webb.